with tradition, commerce with culture, enterprise with entertainment, and development with dependable management. With this beautiful thought, I would like to welcome our dignitaries, Srimati P. Bharti Ma'am, Secretary, Department of Science and Technology, Ms. Kavita Shah Ma'am, Director, IT and E-Governance, our esteemed panelists on the dais, all our business leaders, and all our participants at Vibrant Gujarat Regional Conference 2026. Please welcome all of them with a round of applause. Today, we all have gathered here with a special two panel discussions related to quantum technologies, which will be the first session. And the second session would be on animation, visual effects, gaming comics, and extended reality. Quantum computing represents one of the most transformative technological advancements of the 21st century. By leveraging the principles of quantum mechanics, quantum computers have the potential to solve complex problems that are beyond the capabilities of classic computing systems. As emerging technologies continue to redefine industries, Gujarat has a unique opportunity to position itself as a leading hub for quantum research, innovation, talent development, and industry adoption. The proposed panel discussion aims to create awareness, facilitate stakeholder engagement, and explore opportunities for developing a robust quantum ecosystem within the state. Now, let me take an opportunity to introduce our panelist, Dr. Amit Singhi, Director, IBM Research India and Chief Technological Officer, IBM India and South Asia. Please welcome sir with a round of applause. We have Mr. Sudhir Nayak, CEO and founder, N-Cube Semicon Private Limited. He is Executive Director, Midwest Region Head and Treasurer at Indian Electronics and Semiconductor Association. Please welcome sir with a round of applause. We have Mr. Nilesh Dande, CEO and co-founder, 42 Labs. Please welcome sir with a round of applause. We have Mr. Sumant Parimal, founder and director, Inogress Ventures and chief analyst of Five Jewels Research. Please welcome sir with a round of applause. And we have Professor Anak Bhaumik, Assistant Professor, IIT Gandhinagar in the Department of Material Engineering and IIT Gandhinagar. Please welcome sir with a round of applause. We would also like to welcome Srimati P. Bharti ma'am, Secretary, Department of Science and Technology. Please welcome ma'am with a round of applause. To moderate the session, we have Mr. Pranav Pandya, co-founder and chairman at Dave Information Technology Limited. So to moderate the session, we have Mr. Pranav Pandya, co-founder and chairman at Dave Information Technology Limited. Please welcome sir with a round of applause. Over to you, sir. Yes.
Remove those two chairs. Let's bring the panelists together. Yeah. Okay, so good morning, all of you. Don't say sir, please. You are here to have a dialogues with us. But the format of the panel will be our speakers, enlightened speakers are there with their extremely valuable experience. So they'll be sharing their thoughts vis-a-vis questions or the points that we'll be putting before them, looking at their personal experiences. Having said that, looking at the paucity of time, what we'll be doing is we'll just listen to their deliberations, their thoughts first, and then later there'll be, if the time permits, there'll be a question answer session. Alternatively, whatever queries you may have, you can always reach out to them individually also through email. And given the time, they will come back to you. So we'll try to follow this pattern. So quantum, the word kind of dates back to the, if you look at the word origin, the Latin word is quantus. So it's basically a quantum is a, if as a quantus, they are trying to say a particular amount or aziz, what you see aziz or a particular amount of aziz. So that's the point on which it works. And that's how the word quantus resulted into quantum being used by Max Planck. Correct me if I'm wrong, Sudhir bhai. And then later on, even Einstein used it as a quanta. And then the Einstein used it from the point of view of light, and Max Planck used it from the point of view of energy. So, and later on, it became very popular, the quantum theory, the quantum technology, and quantum technology had its own various offshoots. So with that, I have certain points which I wanted to share from the point of view of the state of Gujarat. So with all due respect, ma'am, on behalf of the state, there are certain points which I wanted to highlight. I'm sure you all are aware about the word quantum computing now, because I am sure, I hear that we have got students from a particular track of quantum technology. We are aware of, you must be hearing the word quantum communication, quantum sensing, and quantum materials. So while our colleagues here or esteemed panelists here, they will try to address this in their thoughts. But in case if you have any further queries or questions onto them, you can always ask it. So Gujarat is predominantly an MSME state, MSME driven state. And we know we try to bring the theories or the experiments of the colleges or the universities or the academia into an applicability or engineering applicability. So we as Gujarat Electronic and Software Industry Associations, whom I represent, it's a community of electronic and software industry technology ecosystem of the state. We have put in our thoughts. So as an MSME, there are areas like logistics and related optimization, where we can actually think of applicability of quantum technologies. There's deep tech R&D acceleration and cybersecurity and compliance. So when I say logistics, we are talking of supply chain and logistics big time. Gujarat is one of those states which is a spread across, there is a uniform spread of the industrial development and whatsoever of the other development parameters are considered. So can be a classic experiment lab where the government, the industry, the academia, and the technology ecosystem can come together and put this into practice. Same goes for accelerated product R&D, where chemical, textile, pharmaceutical MSMEs, in clusters like Vapi, Ankleshwar, and Anand, and etc., they can come up with the accelerated product R&D by having the labs at their own places, along with the academia, which is nearby. So either it could be the academia or the industry itself can in-house those. And this bonding between them can be facilitated by the government. So, and so forth. There are, and obviously, since we are talking in terms of using quantum computing, we are going to have extensive use of cloud, and therefore cybersecurity will kick in. So we'll have to take a note of that also. So these are few areas where we can actually think of Gujarat as our state playing a role, making inroads as far as quantum technologies adoption is concerned, adaptability is concerned, and who better than our colleagues here. So with that, we will avoid the detailed biodata of each of them because I have a list of it. But I would straightway jump on to the queries that I have in mind for them. So Sudhir Nayak ji is a doyen of the electronic industry of the state. He was just kind of explaining to us while we were sitting there in the speaker lounge that I think his birth and the birth of solid state were together. So Sudhir bhai, the first query from me to you would be, we heard about you speaking in terms of lab-grown diamonds. And Surat, moment the word diamond comes in, Surat and the rest of the South Gujarat also comes in. So I'm sure you have this quantum research-related lab-grown diamond activity going on. Why don't you please throw some light on that? And in fact, it will have a direct applicability in the mind of upcoming students also. Please.
Thanks, Pranav. Thank you, madam, for this opportunity. I am audible? Okay. So, today, semiconductor has become a buzzword. And no doubt, Gujarat is the leader when it comes to semiconductor manufacturing. As well as designing also, now Gujarat is picking up. If you look at the projects, out of 12 projects approved by ISM, 6 are in Gujarat. When it comes to investment, 70% of investment in terms of real dollar is in Gujarat. Now, what is the significance of semiconductor when we are trying to talk about quantum? But I consider quantum as a big brother of semiconductor chip actually, because it has evolved once the semiconductor has evolved. Now, I think the gentleman sitting next to me, Amit, his company, IBM, in last 3 days before, they came out with a chip which is a sub 1 nano. People were talking about nanometer. They are talking about less than 1 nanometer. And you know that even this mobile phone, let's say i15, chip carries nothing less than 16 billion transistor in a single chip, and which are on the node of 2 nanometer to 3 nanometer. Now, what this number means to us, that as the density of semiconductor transistor increases, it becomes more complex. It generates more heat. And like a human body, if you look at our body, so we have a 2 hand, 2 legs, 2 ear. When did it develop? It got matured few thousand years before. Afterwards, there is no growth. Nobody has 3 ear and 3 legs or something like that. We stop growing. But we stop growing physically, not intellectually. The generation G, like Elon Musk and others, are highly intelligent. Same thing is happening when you go to sub-nanometer. They are building the chip which is going vertical. Now all these issues comes to the power. Now what is the relevance to quantum? Same thing is happening in quantum. If you go back to the data center, today what is the biggest issue? Data centers are measured in gigawatt and not how many bytes it stores. Simple example is I have a freezer and I have a 10,000 pizza inside, and I have a furnace where I can cook 10 pizza. Then the limitation is the oven and not the number of pizza. Same thing is bytes and energy. So energy is the Today only I read in the newspaper that because of the heat, France and entire Europe, the temperature has gone up by 4 degree, and that has created big issue in energy consumptions for data center and other issues. Now, for the further growth for computer as well as for data center, the silicon is the culprit for heat. So whatever advancement is happening in semiconductor, same advancement is happening in material. And that is where the lab grown diamonds are becoming most relevant. And silent revolution is happening, fortunately, in Gujarat and in Surat. I am fortunate to associate with few companies, and I think there is a limitation of time. I will not talk more about what is happening, but let me tell you that in coming 5 years, I see entire silicon will be replaced by lab-grown diamond. Why so? The silicon thermal conductivity is extremely limited. It is in the range of 300 kelvins per watt meter actually. Whereas lab-grown diamond has 2200. So what people are trying to do is to grow the lab-grown diamond CVD. So chemical vapor deposition, that is the process it called. It mix methane and helium, and methane has a carbon and helium is put the pressure, and then by layer, polycrystal diamonds are made. There is a system called nitrogen vacancy, or I call it nitrogen valley. So one atom of carbon is removed and nitrogen is put there actually, and next is kept empty. Because of these 3-4 phenomena, tell me, just give me 2 minutes before I have to stop, because I can talk for full day on this. So what happens is that today, because of this heat dissipation problem, okay, so because of this, today we have two major problem. One is the heat. We have to operate most of the high qubits in a helium chamber at 1 Kelvin, which is minus 73 degrees centigrade. They are extremely sensitive to temperature variation, physical variation, any noise. The whole information gets lost actually. That is where CVD has all these characteristics built into it. If you can make the quantum computer using CVD, you can operate at room temperature. It is sometimes used as a cover on the quantum, on the qubits, so that it becomes insulated. And most important characteristic of lab-grown diamond in quantum is the sensor. Widely accepted norm is the CVD sensors. Now I will give you only one or two examples that with my friends, they have built currently 4-inch wafer where the diamonds are grown on silicon. Before that, they have taken two more steps. Instead of going directly to the replacement of silicon, they have put lab-grown diamond in aluminum and copper. Now, if you mix lab-grown diamond and copper and lab-grown diamond and aluminum, it can get at least 2 to 2.5 times better conductivity than silicon. So all junctions and other things are used by CVD. So CVD has extensive use in quantum. And if you have heard the news, madam, Odisha government has recently announced 72,000 crore worth of lab-grown diamond projects. And I'm pretty sure, this is my hunch, that it is not for lab-grown diamond. Lab-grown diamonds are enough in Surat. But I think they are looking at something bigger than this. I can explain more, Pranav. I will stop here. Any questions related to lab-grown diamond for quantum and semiconductor, you are welcome to talk to me offline. Thank you.
So, Amit, IBM computing, the straight question to you is quantum versus classical versus GPU. I think that's what we were talking about. So why don't you please go ahead with that?
Okay. Yeah,
I'm
so
sure you have got young brains here,
yeah,
eagerly awaiting to listen to you.
who probably know more than me already, but I'll try my best. So for those who don't may not have spent time on it, we've been using classical computers for a long time in all forms, in our phones, in high performance computing, supercomputers, in GPUs. All of these are basically using binary arithmetic, they're using digital computing. And with quantum computing, it is a completely different way of modeling information. It does not use digits, it's not digital, binary, anything. It tries to use the quantum mechanical principles that we see at subatomic level. So, for example, if you have an electron, right, we may remember from middle school that, okay, there's electrons in orbitals around an atom or a molecule. But some of you may have studied that actually an electron has a wave function. It is spread across space in a probabilistic way. And if a silicon atom has X number of electrons, each one has its own wave function of how it is distributed probabilistically. But it is in a state, right? Now, the wave function tells you, if you try to solve it, it gives you probabilities of what is the probability of it being in this state, what is the probability of being in this state, and so on, right? So that means one particle under the covers has a chance of being in multiple states at the same time. The total chance has to add up to one, right? It has to be somewhere, it's not nowhere. But it can be in multiple states until you observe it. When you observe it, you will only see it in one location, right? How that happens, that's a whole other question. So, but imagine that you could make a computer where instead of these bits, you have qubits, where a qubit is like that electron. It can take multiple states. A bit can take two states, 0, 1. But it can only be in one state no matter what you do, right? The probability of it being in both states is 0 at a point of time. But in a qubit, the probability of the qubit being in multiple states is not 0. It may be in multiple states at the same time, mathematically speaking. That is at the core of it. Now, once you can create this kind of qubit that behave like real quantum particles, now you can exploit all the quantum mechanical principles of superposition, which means if I have, which basically this combination of states, that I can have a combination of states, or entanglement, where you say, okay, I take two electrons or two photons and I can put them both in a correlated state. So now if I move one electron to the moon and I change something, this will also change. And this is some magical thing, right? But it is a fundamental property of quantum mechanics. So now you have, instead of these bits, which is just like a storage, you have qubits, which actually have all these complex properties. Question then comes, okay, so now how do you do calculation with this? What is it? You can't add qubits. Like, what can you do with it? And that's where a very whole exciting field of quantum information science, quantum algorithms is now booming. So there's, at a broad level, you can think that there are two parts to this quantum computing. One is making the hardware, making the qubits, but making the qubits to be programmable, making these systems where you can have thousands and thousands, millions of qubits, everyone you can control very precisely. You can get rid of the noise that Sudhirji was talking about. That is the whole hardware engineering problem. And then there's a software and algorithms and computer science problem, which is, what do I do with these? How do I solve some real problem? If I have an optimization problem, like I have to come up with the optimal scheduling of all the trains in India. Now that's a very complicated logistics optimization problem. Indian Railways solves it using their techniques. But in these complex problems, always you have to simplify it from the true version of the problem so that you can solve it with classical version. Can I model that original version more accurately now that I have more complex representation in some clever way? So this is a whole new dimension that gets opened up because of quantum computing. It opens the possibility of us solving these very hard problems, computationally hard problems, which we couldn't solve in an accurate way using digital computing, now with quantum. Now, this is a promise. it's not happened today, right? We are still in a research domain where people are working on the hardware engineering, people are also working on the software research. But we know from the theory of quantum mechanics and quantum information that if we can solve all these engineering problems, then yes, that promise exists to actually solve the computational problems. One example is factoring large prime numbers. So if I give you a prime number, factoring a number into its primes. If I give you a number 15, and I said, what are the prime numbers? You can tell me, 3 and 5, very easy. But if I gave you 1,562, then you'll need some time, right? If I gave you a number with 2,000 digits, right, maybe you won't meet for some time. So, and a lot of the cryptography we use to encrypt data that we send on the internet or that we store in a cryptographic form, they use these codes, right? So they mix up the data so that even if somebody was able to steal it, they cannot interpret it because it's mixed up. To decrypt it, you need a key. And there's some mathematical calculation, you have to apply the key and decrypt it. Now, you cannot break that because underneath you have to solve a hard math problem to be able to decrypt if you don't have the key. And that hard problem in some of the codes relies on the fact that it's very hard to find the prime factors of a very big number, even using the biggest supercomputers in the world. It'll take you years and years. But we have shown, actually, Peter Shor is the one who first showed it, that if you had a quantum computer that worked at scale, you can solve this problem very easily. You can find the prime. So that means, that's a very hard computational problem. Similarly, in other domains like search, so there are 4 computational problem types where it is believed that quantum will help. One is simulating nature. So for example, if you want to simulate what electrons do inside a lithium air battery, so that you can model the chemistry of it and try to make it more and more efficient as a storage device, increase the lifetime of it. Or you want to understand some complex protein that is on a virus and you want to find the right vaccine that will attach to it. So you need to model the electronic structure and the energy structure at that protein subatomic level. So these need you to simulate the quantum physics and the nature, how it actually behaves, which is very hard to do with supercomputers. Quantum offers a promise in these kinds of things. Second is optimization. I gave you an example of that. Third is machine learning, where you have some data. In the data, there is some pattern. Now, with today's AI machine learning, we have come a long way to detect patterns of different types. But again, with quantum, there is a promise that the kind of way it represents information, you will be able to explore even more structure within the same data than you could classically. So that can supercharge our machine learning algorithms even more when you combine it with the existing approaches. And the fourth area people believe is the area of differential equation, partial differential equations. So if you want to model the hydrodynamics around a torpedo, as it's going through water, or you want to model weather and climate more precisely, again, these are complex partial differential equations. Today we solve them in an approximate way by discretizing, putting them on a supercomputer. But could you model them in a more continuous way if you had qubits-based computers? So these are possibilities that quantum opens up.
Pretty exciting. Pretty exciting. Thank you, Amit. Uh, we'll come to you about the right now itself while we in a continuation, because I think that will be a matter of interest to them. Why don't you throw light on the MOU that you signed yesterday and what as IBM is inclined to do and what does it expect from the Gujarat ecosystem per se as far as your MOU is concerned? Why don't you spare a few words on that?
Sure, that's timely, and thank you to ma'am here for actually enabling it. The MOU doesn't really have much to do with quantum. Okay, it's really about AI and industry. What we are doing there is we are announcing an intent between IBM, the Indian AI Research Institute, IRO, which has recently gotten set up in Gift City as a premier research center of excellence and DST, which is part of the, not DST, is the IT department part of the government, where we said we want to create a center of excellence for industrial AI innovation. So you all know better than me that Gujarat is a state where manufacturing, chemicals, semiconductor manufacturing, all of this is very, very active and is only going to grow. Now there's also a great spark because of the presence of technology companies, organizations like IRO, the increasing growth of academic institutions that are more ambitious around research. So the question is, can we bring AI innovations more concretely with industry in a kind of a living lab? Right? So this will be successful if you imagine a future where there's a living lab where any industry company would like to engage and say, okay, what are the new things happening with AI? Here are some of my ideas and problems. Can some researchers work on those using the technologies that are there in the living lab? Maybe something works, maybe something doesn't work, that's fine, but I can experiment. It will be successful if startups can come and say, oh, I have a cool idea. Can I test it together with the IBM technology and IRO researchers, how it might work in the context of, let's say, Tata Electronics or somebody, right? So the living lab will be successful if it connects the end consumer industry with the researchers using the scalable technology platforms by providers like IBM. So everyone can see how this should work end to end. Right? That is one of the big challenges we have today is bringing things together in an innovation setting, right? One researcher working with a big company, okay, you solve one problem, but you don't know how it will fit in my workflow. The people making workflow engines, they don't have the researchers. So we want to create a space, a safe space where this kind of ecosystem can come and try ideas. And as a result of that, it will create a lot of research, practical research capacity at the highest level out of the state also. This is the.
Thank you, Amit. Thank you. So, Gujarat has quantum computing technology park. It's known as the Greater Karnavati. It is proposed and it is probably functional too. Sumanji, correct me if I'm wrong. And partially function. And we have a gentleman who is part of that, Nikhil. He's very much here. He's part of the quantum technology park. So all of you, for you to know, and my question straightway to you, Sumanji, is that when you signed your MOU with the state government, you had certain plans and you certain thoughts in terms of bringing the investment, how to encourage the quantum computing or quantum technology per se at the across the state rather than few places only. Why don't we do it across the 4 zones of the state? I think that was the basic plan which you had in mind. So why don't you throw light on that and take it forward from here, please?
Yeah, thank you so much. I'd like to thank the DST government of Gujarat for kind of bringing this nice panel here on quantum technology at Vibrant Gujarat. Then last Vibrant Gujarat 2022-24, we introduced the quantum to Gujarat government by proposing this Greater Karnavati Quantum Computing Technology Park here in Gujarat, and that was the first in India. And that was not only for the Gujarat-based quantum startups, but for the entire Indian tech, deep tech and quantum tech ecosystem. And that was a unique vision across the world, not only in India. And now many countries in the world started similar kind of hub building concept, and including the other states in India also started this. So the speed of quantum is now really going very fast, but there are some barriers in among the startups. So few are the deep tech is very capital intensive. You need to build a lot of infrastructure. You need to build a lot of instruments. I think there are many deep tech scientists here. I'm not a scientist, but I am a tech analyst. So from that perspective, and tech entrepreneur, I can tell that arranging the capex and opex is a big task. Not it is a cup of tea for many entrepreneurs. So many founders, they are good in product designing, innovating, building the prototype. But as soon as if you give them a target to bring like 50 to 100 crore rupees fund for scaling their products, then it becomes a big task for them. There we are fitting up. We are creating the entire ecosystem. We are building the infrastructure, common infrastructure facility in collaboration with National Quantum Mission and DST of State of Gujarat. So this infrastructure and the institution like IIT Gandhinagar, this infrastructure will enable our startups to quickly focus on their product innovation, productization. At the same time, the National Quantum Mission has spread across several IITs and some of the T hubs, the technology hubs like IIT Delhi is the quantum material hub, IIT Madras is the quantum communication hub, IIT Bombay is the quantum sensing hub, and IIC Bangalore is quantum computing hub. So there the researchers are innovating on products, but they don't have large scale productization facility. Those productization facility we want in the park. So the innovation and R&Ds which are getting done is those institutions get productized here in Gujarat Park with the help of our startups. So we, in last 2-3 years, we assembled around 30 plus startups, quantum startups and D-Tech startups to get here in Gujarat Park, which we are planning to start from Gift City. Of course, some of its operation, as you rightly mentioned, started in collaboration with IIT Gandhinagar Research Park. And then Nikhil is actually building this quantum chip and quantum qubits in his lab, which he set up way back in 2021, 22 in very near to Science City. I think he is one of the pioneers to bring some of the MNC research center here in Gujarat. One is the Tabor Electronics, which they have announced recently building the quantum computers. So we are actually operating these two startups in our quantum ecosystem, and many more startups are ready to come here, provided we enable their ecosystem, starting from Gift City, and then at the largest scale, we will taking it at Dhulera. So this is the roadmap. So Dhulera is fast emerging as a semiconductor destination. I see a lot of synergy between semiconductor and quantum tech, because one of the quantum tech technology is the silicon-based, semiconductor-based, which is using CMOS technology for building the qubits. And some of the recent investments happen in US are actually on the CMOS technology. And of course, the US government recently invested $2 billion in building 1 billion for building one superconducting fab on quantum fab in collaboration with the IBM, and another 1 billion for the different technology fabs like the photonics fabs and the trapped ion fabs, and another is the diamond-based NV Center fab, and the fourth is the CMOS fab, that is silicon-based fab. So I think the Dhulera, the entire Tata Electronics infrastructure which we are creating, we see a lot of synergy between developing the quantum ecosystem by leveraging the ecosystem of semiconductor we are building in Gujarat. So Gujarat can be positioned as a leading state driving the entire quantum revolution in India. And believe me, next 4-5 years, every transition is going to happen from classical computing to quantum computing, not only from the software side, but from the hardware side also. All MRI machines need to be upgraded to quantum MRI. All telephone handset need to be upgraded to quantum telephones handset. All satellites need to be upgraded to quantum satellites. All classical electronics need to be upgraded to quantum electronics. Every devices, every instrument need to be upgraded to quantum. This is the big ecosystem. There is a big ecosystem requirement for this. This is the mega $1 trillion opportunity. Let's see how fast the Gujarat can run to catch up this $1 trillion opportunity and become a supply chain hub for the global quantum computing and quantum technology, hardware and software. And I think in the call I mentioned, we have to catch the supply chain. We have to become leader in this supply
So I was
chain.
coming to that. Your candid and specific thoughts on terms of supply chain ecosystem. You mentioned that in our call. So I just share those candid thoughts. Few minutes, please, couple of minutes.
Yeah, so right now the semiconductor supply chain, we are trying to integrate in India in that. But the thing is, the semiconductor supply chain is one of the traditional supply chain there. You have the China route, you have the Taiwan route, you have the US route, and some of the Japan routes. But the quantum supply chain is just growing, just building up. So we can catch the dominant leadership position here very easily compared to semiconductor supply chain. So I think this is the right time to become a dominant player in the quantum supply chain. And quantum, as I said, 4-5 technology areas there. Semiconductor is one, lab grown diamond is one, where we can have a quick leadership build up here in Gujarat. And then we have the trap ion based, we have superconducting based, and then we have photonic based. So 4-5 technologies are there in quantum, and for every technology we can build up the supply chain here. So world is looking for us, for enabling that hardware solution for quantum, everything, quantum drones, quantum, television will come, quantum memory will come, quantum network will come, quantum MRI machine I already mentioned, quantum repeater, quantum satellite. It's a huge quantum communication, secure quantum communication, the imaging, everything. You talk about the technology stack, the quantum is going to enter there, because it's a different computation. In silicon, you use the transistor model to do computation. You apply a voltage, you switch on a transistor, you withdraw the voltage, you switch off the transistor. When the transistor is on, it represents 1. When transistor is off, it is represent 0. This is how since last 75 years we are doing the computing. But quantum is, as Dr. Amit was mentioning, quantum is a different paradigm at all, right? Here the computation doesn't happen by transistor in terms of switching on and switching off. Here the computation happens through quantum mechanics. You manipulate the state of the atom, you change the state of atom. Is like a particle in this form represents a different state. If slightly rotate an atom, it represents different state. So one atom, 1 qubit can do infinite computation. In the classical computation, one transistor can do only 2 computation. But in quantum computation, 1 qubit can do infinite computation. That's why I can enhance in the same size of the chip, I can enhance my computing capability million and billion times. I can have in a small chip, I can have billions of gigabyte of storage, by using the quantum memory. So this is and in quantum network, nobody can hack the quantum network. Nobody can hack the
So
quantum
we have got our
communication.
colleague here. He will speak on that.
Thank you.
Don't take me otherwise. I know you are extremely passionate about what you are doing, and I'm sure our quantum technology park will go great time with that. So just to strike a balance, it was going slightly over there, so I'm bringing it here. Nilesh Dandeji is a gentleman who is involved with national mission also, quantum tech with Government of India. And he is doing extensive work in terms of quantum communication. Let me put it this way, okay? On a global way. I wanted to say a few more words, but I said, let me restrain myself. So why don't you straightway go into what you wanted to speak in terms of making the quantum communication safe, and why so? What is the significance? I need not say paucity of time, but please go ahead. Thanks.
So I think Amit has mentioned it earlier, right? So before I kind of jump into it, just by the show of hands, how many of you are familiar with a term called as a Q day? Show of hands. Okay, very few. Okay, Q day is the day when they say that there will be a sufficiently large quantum computer that will be available, which can break the traditional cryptography. Okay, again, a show of hands. How many of you aware of the word called as cryptography? Okay, a lot of it. So I don't need to explain the cryptography to you, right? See, cryptography is a silent worker. Okay, before, just to give you a perspective on that. See, when we go to Chaiwala today, right, and when we basically do a UPI transaction, do you know how many hops it basically takes? Approximately 17, approximately, right? 17 hops. In all of these 17 hops, there is a cryptography that is happening, right? You are securing those 17 hops using the cryptography part of it. What if? What if there is a viable quantum computer which is able to break this cryptography? So I'm taking an example of a UPI. However, The cryptography exists everywhere. Okay, right from accessing a website to doing a transaction to national critical infrastructure, right, to defense to government, everywhere we are basically getting secured with a classical cryptography part of it, and that's the threat. And what's the biggest threat? And I think we all should actually understand what is the biggest threat today. See, National Quantum Mission today has earmarked around 6,000 crores, right, for our journey. What is our neighbor doing? How much money they have earmarked? Till date, they have spent around $16 billion spent. Okay, not earmarked. Spent $16 billion. March 2025, they have declared a scheme for their startups. March 2025, they have declared a scheme for startups. $128 billion were earmarked for the startups. What is the threat? If our neighbor has it, what can your neighbor do? Right? Okay, the second question is, now that's the Q day part of it, right? When the quantum day will arrive, and jury is still out there. Somebody says 3 years, somebody says 5 years, and all of that. But can we afford to wait for that much amount of time? Why? Why not? Okay, there is something called as a harvest now decrypt later. I think most of you may have heard about it, whoever have done the chat GPT. I'll simplify it for you. See, let us assume that, let's forget about the IT world. Okay, let us assume that we are keeping our secrets, government secrets, banking secrets, sensitive data in the locks, lock and key, right, inside trunks. And we know that these trunks cannot be broken for at least 3 years. Okay, what the enemy can do, they can just basically steal the trunks today, okay, and keep it with them. So when the key is available at that point of time, right, they will open all of your secret. Has that happened? Yes, it has already happened in the world, right? So that means I don't think that we need to wait, especially for a quantum communication domain. We don't have to wait for the future to arrive. We need to understand future is today, right? We need to get protected ourselves today. Okay, and I'll just take a last 1 minute as on how to protect. Okay, so from the protection perspective, okay, that's where the quantum communication comes into the picture. I think Suman mentioned it earlier, right? So what is quantum communication? There are two parts to the quantum communication. Okay, one is the hardware part of it, using quantum itself, quantum machine itself, to establish a secure communication part of it, right? Which is called as a quantum internet or quantum key distribution part of it. And the second portion, which our students should be familiar with, especially the interest wherever there is a cryptography, it is called as post-quantum cryptography, as it sounds to your ear. Post-quantum, the cryptography which will survive in the post-quantum era as well. These are newer set of algorithms which even Peter Shor's algorithm will not be able to break that. Okay, and that's where the migration plan has to begin today. Okay, so if you look at now NCIPC, they have already started sending out a letter to national critical infrastructure saying, what is your quantum readiness? Okay, and that is the question, not only for the government or defense or the national critical infrastructure, because who we are also a supply chain to all of these guys, right? So that means eventually this regulation is going to hit me as well as an industry, right? So that means I need to get started prepared today. Second key important thing that we need to remember in this domain is, see, there is something, okay, earlier there were only two algorithms, right? RSA and ECC. Don't worry about the jargon part of it. Two algorithms were there. Now, in the post-quantum, there are four algorithms. However, in the coming days, there are 18 more candidates because newer and newer algorithm has to be invented, okay, to keep you safe. What does it mean? It means my infrastructure needs to have an ability to change those algorithms on the fly. My UPI transactions, right? My banking transactions. That is what is called as a crypto agility. Okay, these are very important terms. And this migration is extremely crucial. Why? See, imagine cryptography is like this room, right? Inside this room, whatever lights and fans are running, there are wires inside. Okay? Imagine without impacting this operation right now happening, I need to change the cryptography. I need to change the wires and on a continuous basis. That's the concept of a migration, the cryptographic agility. Okay. So don't want to sound paranoid, but it is cybersecurity is all about being paranoid, right? You if somebody is telling you, boss, तुम्हारा lock ना एक दिन टूटने वाला है, will you wait for that day to arrive? No, you will start changing your locks today. It is as simple as that. Thank you.
While he made it sound more like a science fiction also at times, to me at least, I don't know, but he was pretty witty and funny too. Thank you so much for making things lighter here. Dr. Bhomik, I know you were heading the Department of Material Engineering at IIT Gandhinagar, and we are really blessed here to have you, because when I spoke in my introduction, I spoke about quite a few things in material part of the quantum technology is one of the key. So while you may throw light on what exactly you are trying to align as far as your department is concerned in terms of quantum technology, but bridging this gap from lab to market, and the talent pool is the key, which we keep on discussing continuously. And it's a globally talked about topic also, not only in India. The sheer requirement of the pool of talent in terms of advancing or embracing this quantum technology way would be required. So what are your thoughts on that? And what is IIT Gandhinagar doing for that? So दो चीज है एक साथ आपके लिए.
Thank you. Thank you very much. So, first of all, I'd like to thank all of you for being here. So, when I teach quantum in my class, the first thing that I ask to my student is that, why do you think quantum is very fancy? Okay. Many of them look blank. Okay. Many of them think like this quantum word is a very heavyweight kind of word, like quantum, AI, this thing, that thing. But quantum is very simple. Quantum means you can't predict. Then people will say, ki, sir, if we cannot predict, then what's fun in that? That's the fun, right? Because suppose if you give a password and if it's very predictable, very nasty, right? People will be going to hack it right away. What about if you're creating a quantum architecture, a quantum material or device to make your password unhackable? That means you are trying to randomize your password in such a way that not even you can also break your password, something like that. So with respect to that, the materials forms the very key, very, very key. Now, in case of any advanced deep tech nodes, we always see that US comes first, most of the times. Why? Most of us might not know, because they give a very good focus on the materials. Because you see, like without materials, things can't be made, right? If you are trying to make a IC chip, and if we don't know how to make a single crystalline silicon, then we are in the middle of nowhere, right? That means we are dependent at any point of time to import the substrate, which is silicon. And you'll be amazed to know in India, there is no one making single crystalline silicon. That means we should focus on the materials part. Okay. Now the next thing is that what make the materials grow? The tools, right? The high-tech tools, it makes the materials grow. Semiconductor fab, there is one big company known as Applied Materials who ships very high-tech tools. And you'll be amazed to know in Santa Clara, most of the applied materials are Indians, because we are having very good brains. Our theory part is extremely good. We are very good in maths, we are very good in physics, chemistry. Anywhere, any sort of math problem you give, we are pretty much good in that. Hands-on, experimental, we are a little bit lacking. So that's where IIT Gandhinagar puts in the flavor, like you do things, you learn. Quantum by itself, for a long time, it's being thought like, there are a lot of random physics equations. बहुत कुछ इसमें याद रखना पड़ेगा. Very, very big equation, there is wave function, Hamiltonian, this thing, that thing, But what we teach to students is that, so you really need to know those equations, but you see how quantum is utilized in a real life. What is a quantum material? Now, let me ask you a question. What makes a quantum computer fancier than a classical computer? So how does this computation happens? This happens due to the help of bits, 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 right? So classical computer, it has n bits, so it can do n kind of work, something like that. So in the case of quantum computers, so if you're having n number of bits, the qubits can do 2 to the power n kind of work. That means with 2 bits, you can do 2 kind of work for a classical computer. Quantum computer, you can do 2 to the power n or 2 to the power 2 or 2 to the power 2 is nothing but equal to 4. That means you're having lots of friends to solve problems in the quantum domain. That's what we need, right? We need more friends to solve problems. Quantum technology will give you more friends. Now, quantum technology can be subdivided into various parts: quantum sensing, quantum computation, quantum metrology, materials and devices. Now, we should really focus on the hands on part, because you see, if we are totally relying on the equations, equations might help us to score very good grades, by the way, okay, which we all need, okay. So beyond that, if we are really willing to make a product, then we should have a very good hands-on. So with that, we are having a very good help from National Quantum Mission to build our own quantum lab at IIT Gandhinagar. And all of you are definitely welcome to have a look at it. Now, with respect to that, as most of us have also talked about, quantum and semiconductor goes hand in hand, okay? Gujarat is the land of semiconductor. Gujarat is the land of diamonds. So definitely, why not Gujarat can be a land of quantum, right? Because you see, quantum diamond is that kind of material. By the way, it's very easy to grow diamond. Every day in my lab, we actually do, okay? Because my lab, our specialty is to grow doped diamond, undoped diamond, utilizing CVD process. Very easy to grow. System, it's totally custom built. That means the system has been built by my BTech students, master students, PhD students in the lab. Nothing has been procured from outside. That means it can be done in India, right? We should have this motivation ki, let's not try to make our life easy by just buying random parts from US, China, right? Let's try to build those parts. Who can build those parts? We only can build those parts, right? We only should come together to build that sort of program. We should have a lot amount of hands-on to teach our students. Okay, so what is a pressure sensor? What's in it? How does a pressure transducer works, right? Who will be going to train? When all of us will be going to meet together, then only that can be possible, right? Because at IIT Gandhinagar, there is a very big stress on, what kind of products you can make in the lab, what kind of materials you can make in the lab, what is your roadmap to translate your materials to actual devices. Now, as we have heard about this term known as valley of death, so which means that, up to a certain point of time, most of the fancy things happens in lab, and after that it dies down, because some helping hand we need to translate that product from the lab to the actual market. So that can only happen when we'll be going to sit with startups. Now, whose work is that? It's work of us only, right? No one will be going to help us unless we help ourselves. That's what I feel. So with respect to the funding sources for quantum, I feel we are having plenty, but we should channelize them. We should be able to, build this kind of workforce who are equally trained on the theory part as well as on the actual hands-on part. That hands-on part I'd like to stress very much, because, in my grading scheme, 60% marks is on hands-on, 40% is on theory. That means, definitely to improve the quantum scenario, we should be very good in hands-on. Now with that, semiconductor part also, IIT Gandhinagar is doing extremely good. Recently, we have secured a very good project known as Samarth from MIT. So wherein we'll be going to have very many state-of-the-art tools, something like PECVD, ICPRI, all the fancy tools that you can see in a semiconductor fab. For the very first time, we'll be going to see in any IIT, that will be IIT Gandhinagar. Okay, so any one of you who really would like to get trained on that, you are pretty much welcome on that. Because, the major motivation of Samarth project is not to build any fancy devices, is to train you guys, is to make you capable, so that once you are getting trained these kind of facilities, industry will be going to come to hire you. You won't be going to them with your CV, because they will be going to see the potential in you. So what as a students we should do for quantum? Quantum is not a cup of tea for just single branch. it has been a very wild notion that, quantum is all about physics. No, definitely no. Quantum involves physics, materials engineering, chemistry, computer science, all branches coming together. It creates quantum and semiconductors. Now, my last thing will be, like when can quantum thrive? When qubits can be formed on silicon wafer. Then only those quantum can be marketable. Because silicon wafer, you see, like all of the process nodes, what's developed in semiconductors are based on silicon wafers. Okay. So that means if you're able to create qubits onto a silicon wafer, that's a ready product sellable in market. So with that, over to you, moderator. Thank you.
Thank you so much. Thank you. I think you've done justice to both the points that we had discussed, and thank you so much. नीलेश जी, आपसे एक बात पूछना भूल गए थे नेशनल मिशन के बारे में. सो व्हाट इज द करंट अपडेट, और अपफ्रंट आप क्या सोच रहे, व्हाट इज दैट फर्स्ट दैट यू वुड लाइक टू अचीव, द ग्रुप दैट यू आर पार्ट ऑफ, एंड वेयर डू यू सी गुजरात प्लेइंग अ रोल देयर?
So let me update you on what is National Quantum Mission is doing in the space of a quantum communication specifically. There was a national level task force that was set up specifically to look at the migration plan for the entire nation, not only very specific. Okay, so how do you migrate from the classical cryptography to the post quantum world inside? The paper is out, guys, are there already. It is available on the Department of Science and Technology, India Department of Science and Technology. And so there were two task force inside that. One task force which was basically supporting the quantum migration, and the second was how do you now my company for labs we actually post quantum space, right? However, there is no way to test that out today. It is just my claim. Okay. So the second task force was basically designated how do you test the quantum systems as well, especially into a communication domain. Okay. That was the second task force. So both of these task force now have been basically assimilated, and the public consultation paper is already out there onto the department's website, right? So everybody should make use of that and go through that inside. Okay. Now, coming back to the state of Gujarat, I do believe that Gujarat has an immense potential because the right ecosystem actually exists here. See, I'll tell you guys one thing. I happened to meet Israel as well. Okay. And there were, we visited around 8 companies. Some were working in photonics, some were working as ion traps. So around 4 companies into quantum communication space, quantum computing space, one into communication space, few into materials, and one was also into error correction space. The ecosystem that they have built is you have an Haifa University in middle, right? And then you have the industry park, which is around surround that. We can definitely replicate it here, with IIT Gandhinagar being basically the hub and industry surrounding it, right? And industry, this is the space, this is an emerging field. That means you'll need always a research backing to your industrial applications part of it. Okay. So I think the model is already solved. It is all about basically getting out there and implementing it here so that our quantum ecosystem can actually thrive inside that. Okay. Finally, I always tell into all of the public forums the importance of the quantum communication for the national sovereignty. Why is that? Why I'm using the word national sovereignty in the space of quantum? See, cryptography from the age-old medieval times, the nations which have done well, they were inventors of cryptography. Start with Julius Caesar. Guys who have studied cryptography, we are aware of Caesar cipher, right? No computers were there, right? So, and as on date today, unfortunately, as a nation, we are living on a borrowed standards. I would use borrowed standards. Why? Because when we talk about cryptography, we say NIST, which is what is NIST, boss? NIST is a US government body. It comes under Department of Commerce, right? And the nexus between NSA and NIST has been proven. So I think it is a high time, and this I have been shouting in multiple forums, and there is another initiative which will shortly begin under DST, which I think Gujarat also can participate very, very aptly, is to formulate India standards. Do you know, if I create a hardware security module today, hardware box, where does it get tested? Made in India, get tested in the US. Barabar? Unfortunate thing. Okay, so that is the second piece. And I do believe we can play a large role in actually, because there is a lot of work that is involved. There are testing centers, right? There are academics that will be needed. There is a cryptanalysis that is needed. So a lot of work can be done into that area as well. Finally, before I conclude, okay, I would always tell one framework for all of us to remember. How do you remember a quantum communication, and what we need to do as a country, as a state, as a startup, and as an individual? We are a land of Shiva. Okay? The framework that you should remember is Shiva. When you speak, when you think about quantum communication, what is the relevance? S stands for sovereignty. We should have our own standards. We should be self-reliant as far as quantum communication is concerned. You cannot trust, especially into current geopolitical scenario. H stands for hybrid. What is hybrid? People, policy, right? And the products that has to come out there. I stands for infrastructure. Unless and until we have infrastructure, which is like IIT Gandhinagar and all these guys are building, right? It cannot happen. Intelligent infrastructure backed by an identity. V stands for Vikasit Bharat. Beautiful vision. Forget about the political alignment, but if you look at it from the vision perspective, whether I am whatever I'm doing today, whether it is aligned with Vikasit Bharat or not, and sovereignty comes in. Okay, and last A, authority through a quantum assurance. We should have our own authority as far as quantum assurance is concerned. Thank you.
Well said.
So most of us have, most of my esteemed panelists, I have asked 2 points to address. I have reserved one last point for you, Sudhir Bhai, because that amounts to that consciousness scenario which we talked. But I would request, looking at the positive. So while we started bit late, so I'm just borrowing around 10 odd minutes further from here. A few minutes, Sudhir Bhai, and then we have a few more things from my side, and then we'll hand it over to the our colleagues from the government. Sudhir Bhai, over to you about the consciousness aspect vis-a-vis the quantum technology, and how you can make it sound more applicable to us in the layman's word. I would put it this way.
Hear me?
So, Sudhir Bhai, આવી રીતે કરવું પડશે.
Hello.
Yeah.
Can you hear me now? So very interesting question. But I'll pick up from both of my colleagues, one on the right hand side and one on the left hand side. He talked about Shiva. So I just want to add there, if time permits, you can read. There is a book written from Shiva to Surrender. So I think that is the book you should pick up. The equation of quantum is done by the scientist. So the whole thing is mapped there actually. That is number one. Number two is that Shiva's statue of 3 feet in 21 or 22, 1921 or 22, 2021 or 22 was gifted to Switzerland. There, like a Copenhagen framework, they are working on this. An entire Shiva statue of doing this dance has been linked to the current happenings in the globe actually. And it is linked to the, there's a nuclear research center is there in Switzerland. There it has been gifted. And they are adopting from Shiva every mudra. So it's worth knowing. That is number one. Since you talked about Shiva, I just recollected. Number two, Amit, my friend, he talked about two things about quantum computing: superposition and entanglement. Now, if you look at the superposition, he also said, and I think Suman also said, that once you look at the atom, till then it is not in a definite state, or you cannot measure the speed. That means somebody has to look at it. Now, till you look at it, it is in uncertain positions. So there is a phenomena which is called the double slit experience and all those things. People may be familiar that where the wave collapses. So there is a detector. If the electron beam is thrown, it goes to double slits and then it is on the screen. So the moment you put a detector there, it gives a different pattern actually. So there is a debate going on between scientists and philosophers. I think he referred about Max Planck. In 1931, what he quoted, I will tell you in the last actually, but quantum is relatively 100 years old. It is just came in the light in last 3-4 years. But quantum has been in existence. In between, it was sleeping, like what our frog does. Till monsoon comes, they do not come up actually. Now, let me go back to this position that there is a scientist, he got the Nobel Prize in 1963 on physics, Eugene Wigner. Now, he was very different kind of a thinker and scientist. So what he said, that when you do the measurement, that measurement instrument itself is made of quantum. So somebody has to measure that and look at that actually. So who is that actually? Who is doing the looking? Somebody is looking into it, whether instrument or anything else. So who is doing that actually, of looking part of it? And there has been two philosophy on that. Western philosophy says that electrical signal, you see the things, electrical signal go to the neurons, they generate the electrical waves, through nerves it goes into the brain, and there are 100 neurons which recapture the thing. Whereas in Bhagavad Gita, in verse 13.1 and 13.2, 6,000 years before, there has been made distinctions between seer and seen. There are two Upanishads. One is Drik Drasya Vivek, where there has to be two things, object and subject. Unless and until there is a separation, you cannot see these things. So when they ask Arjun, Krishna explained him that he gave an example of real life. See, the Gita and all those things, they are not stories. They ask you to test it, everything, whatever they said. He said, when any thought arises in your mind, somebody is aware about that thought. And that awareness is not in the thought. Awareness is outside the thought, then and then you can feel there is a thought going on. So two things are distinct. And on the other hand, the quantum computing says that there is a entanglement. So one electron is suppose here, an entangled electron is on different universe even. And if you change this bias, it will change there also. Now, in our Vedant, it is already said that Brahman is one and everything is connected. There is nothing like you and me. I think this has been established more than 6,000 years before, which quantum is not able to even explain today. So there are three problems which are not solved yet, and it is we are hoping that quantum may solve. First problem is known as the hard problem of consciousness. What is the hard problem of consciousness? It says that when I look at the flower, and if it is a red flower, the sunlight falls on the apple, red apple or flower, it goes to my retina, it gives the electrical pulses, and then it goes and it reconstructs the flower, and there is a memory. From memory, it find out what AI is doing today. Same thing is done here. And then it says that it's a red flower. Now everything is explained by physics and by software, but it is not has been explained that how the feeling of red thing comes in. To be more simplified version, the experience of getting pleasure of seeing the red flower can never go into the quantum computer, or it cannot go into any AI. No feelings can be generated in any of this machine, and I don't think that will be generated ever. The primary reason is that there is as we were talking, we started from the Wigner definition that there has to be an observer. And that observer also is made of quantum particle. So there has to be another observer who should observe that quantum fellow, and there should be another. There is a change. So how to break the change? He said there is a very, very significant role of consciousness. Unless until the consciousness is there, you cannot feel any of these things. And I think people are struggling for 100 years. They have hit the wall, all scientists, including quantum, has also not been able to solve. That is number one. Number two is, as I said, that entanglement. Finish. Entanglement also, I will just, I think I have to stop it. But they said nothing is solid in the whole world. Everything is moving. Two examples, which what we think is never right. We are right now sitting over here, but Earth is rotating on its axis at around 14,000 kilometers an hour. Sun is rotating at 8 lakh plus kilometers per hour, and we don't feel. When I travel into flight at 800 kilometers, I can sip the tea. So what you see is not real. So what we are trying to do with the quantum is non-real. And our Shastras and Vedanta, I am not going to 13.22 and others because I have to stop it, but they have seen this long before, and we are trying to just map it now with the quantum. Thank you.
So, completely a different angle. We had a very elaborate discussion on that. It requires another, in fact, a round of discussion. Can I also get into it? So I have to stop myself. But we are at this end of the panel discussion, about to end it. There are a few points, and before I conclude, I would like to take a chance, if that's okay. Take a chance in bringing my colleague Maulik Banshali. He is the currently the chairman of SME NASCOM Council, India. He is fortunately with us, and he hails from Baroda. He is also part of Geisha. So Maulik, just 2 minutes. Wanted to know what is NASCOM actually talking in terms of, or what is the mission it is involved into? While it's part of India mission, but the tech ecosystem. So just throw a light on that, just a couple of minutes. And then I have got 5 points as a tagline, and then we hand it over to Madam.
Oh, thank you. I think it was very enlightening session by each and every. I think each and every one of you can possibly spend at least 40, 45 minutes more on talking what you've been doing. A lot has been covered already. So I think I'll stick to something very important and very pertinent to especially our young entrepreneurs or students who are here. That NASCOM has this something which has been designed with the MATI is Future Skills Prime. And Future Skills Prime, it is a pathway for taking quantum computing pathway, right? How you should possibly get ready, and I think we heard about being ready, and getting readiness is very important, because as we move from quantum advantage to quantum supremacy, Nilesh, as per your point, I think in the meantime, we should also prepare for gearing up for getting our talent ready for that. And I think something like this is very useful, where you should get started actually yourself getting aware with quantum computing. And I think I recommend and I encourage all our friends here to start looking at this. There is a coursework out there, pathway, which you can take it up and get started with it. Another thing is, several times it is understood or possibly misunderstood that it is quantum versus AI. It is not so, okay? Here we are counting and looking at it as a hybrid way of looking at it. So possibly the future models are also likely to be quantum AI and cloud hybrid. So where we start from our advantage to then supremacy in the meantime is very important. And finally, I think for every industry practitioner, as we heard, that quantum readiness is very important in terms of our security, data, and of course sovereignty as well. So start looking in that direction. These are few words I have. Thank you.
I didn't wanted to lose chance of hearing from NASCOM. So all in all, I would like to conclude with top 5 key points which we have assimilated based on deliberation which happened here, which I also had a chance, thanks to moderating this panel. And I sincerely thank my colleagues, because I call them my colleagues because Geisha represents an ecosystem. We are a bridge which connects policymaker and the government on one side, the users and the academia on the other side, the private sector on the third side, and the fourth is we ourselves, the technology providers. And therefore, the colleagues, so thanks for giving me this chance. So top 5 keys, one is implement target funding via the STI policy. So we can mull over this for sure. Geisha has made a note of it. And thanks to that discussion which we had on the Geisha call as among all the speakers, we had jotted down those points. So I'm just highlighting the taglines. Another is create a quantum-ready talent pipeline. So there are specific way forward for that also. We spoke about that, but there are very simplistic way forward, which Geisha and our colleagues from GIL and DST can come together at the directory governance and work on that. Establish regional industry academia clusters. We have got a very good plan for that. In fact, my friends here from Maulik and Devang and Nilesh can build onto that. Surely, as in required, we can sit down with government and work out all the 4 zones, Rajkot, Surat, Vadodara and Ahmedabad. Build indigenous component supply chain, Suman ji. वो आपके साथ मिलके जो हमने सोचा है. This is the 4th point. And 5th is incentivize local startups, ma'am. And quantum as a service is something that we can mull over. It's one of the fantastic options that we have to look into. And I have got clarity of thoughts on that. So with this, we have got a dedicated team in Geisha which can come forward, and our 5 panelists per se also can be part of that. We've got a very detailed thing written here, but then we'll share it with you. So with that, thank you very much for being a patient audience. I know we were supposed to have dialogue, but the paucity of time is stopping us here. You can always reach out to the association, to Department of Science and Technology, to GIL, and the panelists here. You know our names. You can just Google, and you have our all details out there. But having said that, we can also share these details with the friends from here. Thank you so much. Over to you, to the compere. That's not feasible right now. It's not ready, but we can always pass it on. Since they have registered, they can always connect. No, that's what I'm saying. We can pass it on. Since they have registered, it will be passed on.
Our team is there to help you, sir. We'll help you for that. Yes. So thank you so much, all the panelists. Now, after listening to them, we have a very special guest with us, our visionary leader, Srimati P. Bharti ma'am, Secretary, Department of Science and Technology. I would like to call her to please speak some few words on this occasion to guide us with her wisdom. Ma'am, please.
To all, I think thanks Gesia for organizing this wonderful seminar. Actually, yesterday whole day we were talking. Today I felt very happy. Aram se listening all of your very good insights, taking a really lot of inputs. I'm really happy. Suman ji to bola ki we should start running, not even walking actually. Where we are, I think in the quantum still, I feel that we are lagging behind. And we are already excellent progress in semiconductors and other sectors. But quantum is a transformative technology, especially in few sectors like health, manufacturing, finance, and so many other sectors. So quantum mission at the national level is already there. This year in DIT, Director of IT, we have started GFTI, Gujarat Future Technology Initiatives. And we have government of Gujarat has kept lot of funds for these initiatives also. I request all of you, all 6 of you, maybe you can coordinate Pranavji. So what government should do? You have already talked about that Israel model and all. We'd like to listen more from you. 1 hour session is not enough actually. For each individual, we will sit together. Maybe all 6 of you can act as a task force or advisory body for us and give us clear-cut recommendations ki what we should do ahead. See, there is no dearth of money or talent. Like you are yourself, you have a lot of wonderful points and NASCOM and all of you. So give us in points. No need of any a formal letter or anything. So today's seminar may say you can please coordinate with them. Give us points like DIT will be the nodal agency from Department of Science and Technology. Already we have started out some points. Kalpesh will be coordinating with you, Pranav. So we'll be definitely taking point because Gujarat is always at the front end to do anything new actually. And a lot of entrepreneurs are there, startups are there. But only thing is, I know we did MOU with Sumanji. I think he must be, actually he has taken a lot of effort to do that. But Aage we couldn't do much because it's a new thing and we are already tied up with semiconductors. So many things are happening actually. AI and all. Quantum, of course, is very, very important. That's why I thought I should listen all of you. I should get a clear-cut clarity so that what direction we should go. But I agree that we should do it as early as possible and we will do it also. I once again thank you for all of you in good numbers, all of you participate. That shows the amount of interest everybody is showing and lot of potential is there. At the same time, lot of challenges are there. If you don't do it now, we'll be lagging behind. Yeah, yeah. Thank you so much.
Ladies, ladies and gentlemen, as we draw the curtains on these highly insightful sessions at VGRC 2026, one thing is abundantly clear. Gujarat is pacing to move to become a monumental hub for deep tech, quantum resilience, and creative digital economies. It's my absolute pleasure to say a vote of thanks to the Landmark Regional Conference, to our distinguished guest and chair, to our quantum panelist, Dr. Amit Singhi from IBM Research, Mr. Nilesh Dhande from 42 Labs, Mr. Sudhir Nayak, N-Cube Semicon, Mr. Suman Parimal Inogres, Mr. Anak Bhomik from IIT Gandhinagar, and a special thanks to our moderator, Mr. Pranav Pandya from Dev IT, for unpacking the quantum resolution and laying down the 5-year leadership roadmap to Gujarat. A special thanks also to our host and our venue partners and to our audience. A big round of applause to all of you. Thank you. Thank you.